Right, question 5. You are given the complex number z is equal to r 6 theta, where r is greater than 1. You have to show the complex number z square clearly on the Argand diagram. Now z square, applying the De Morby theorem, gives r square 2 theta, where the modulus is r square. Now you are given r is greater than 1, hence r square have to be greater than r. So this will give you the complex number z square with the modulus longer than the modulus of z. And the argument of z is theta, right? And the argument of z square is 2 theta, hence this angle is theta. So we have completed part 1. Now let's move on to part 2, where you ask to find the modulus of z squared minus z. To do that, we need to find the complex number z squared minus z. Now this gives you the complex number z squared minus z. And the modulus is the length of this complex number. So let's say this is A and this point is B. Then the modulus of z squared minus z equal to the length A, B. Right, we move on to part B. And to explain this, we need to look at the theorem of triangle. Now, for any triangle, the sum of any two sides is always greater than the third. So, in this triangle, A plus B is greater than C. So, we're going to apply this concept here into this triangle formed by the three complex numbers. So this will give you the modulus of z squared, modulus z squared minus z, and modulus of z. So the sum of any two signs will definitely greater than the remainder sign according to the theorem of triangle. Hence, we prove. We look at part C of the questions. You are given z is equal to 2 6 theta. The modulus is 2. Then show this is true. Now to do that, we need to refer back again to the Argand diagram. Right. Look at this triangle, and we have the modulus. Right. Given z is equal to 2 6 theta, then the modulus is 2. Oh, sorry, it's 4. This is z squared, and this is 2. Right, because the modulus of z squared is 4. Now with these relations, we use what we have proved in part B. Z plus z squared is greater than the modulus of z plus modulus of z squared is greater than modulus of z squared minus z. We obtain these relations. and apply another relations that we obtain from part B. We get the modulus of z squared minus z is always greater than 2. Therefore, we have shown these relations that we want. And finally, we look at part D. Alright, in this case, you know that theta is equal to pi over 6. And you ask to find the modulus of z squared minus z. Now we again need to refer to the triangle over here, knowing the length 4, 2, and you ask to find this length. Okay. Now, given theta is equal to pi over 6, so we can apply cosine rule, right, to show the values of the modulus. Done.